Hello. In this tutorial, we're going to introduce you to Abaqus CAE, get you familiarized with the interface of Abaqus, and give you a general idea of how to perform a basic finite element analysis in Abaqus. We're going to accomplish this using an example. We're going to simulate the loading of a barbell stand with a barbell, just like the ones you see in a gym. Now, barbells can be pretty heavy, so if you were designing a barbell stand, you want to make sure it's strong enough to bear the weight of the barbell. And one way to do that is to analyze it in Abaqus. On the monitor behind me, you see a 3D model of a barbell. Let's take a closer look at that. The setup consists of two stands holding up a barbell, each bearing an equal share of the weight. We're going to use the dimensions from this schematic. We'll be using SI units, where length is in meters. The stand is a solid block made of steel with a density of 7.8 grams per centimeter cube, a Young's modulus of 200 gigapascals, and a Poisson's ratio of 0.3. When performing finite element simulations, it is not necessary to model every single part of your simulation. Engineers often decide what needs to be part of a simulation and what doesn't, in order to save time and computational resources. We do not need both barbell stands in the analysis. We can just use one and assume it carries half the weight of the barbell. To simplify the simulation further, we don't model the barbell at all, but replace it with a force equal to its weight. Here you see a depiction of the barbell stand with loads and constraints applied. A force equal to half the weight of the barbell will be applied in the U-shaped clamp where the barbell will sit. The base of the barbell stand, which is normally in contact with the ground, will be fixed in space using an Ancaster boundary condition, meaning that it cannot translate along the X, Y, or Z axes, nor can it rotate about them. So let's go into Abaqus and give this a try.
Now, if you haven't already done this, the first thing you want to do is go to File, click on New Model Database, and choose Standard Explicit Model. The other option is a CFD model. CFD is Computational Fluid Dynamics. We are not dealing with fluids in this model, so we're going to go with the first one. Now there's two kinds of models. It said standard/explicit. A standard model is where you're simulating forces and loads acting on an object that's in some sort of equilibrium. Whereas in a dynamic analysis, you might have, say, an object falling off a table, and you want to study how it breaks apart. So you've got a sort of impulsive loading going on there, and you might also be interested in the transient behavior of this object under loading. So you might want to see the stress distribution in the object change over time. And for that, you'd use an explicit analysis. But in our case, we're going with a simple, standard, static analysis. Now what you see over here on the left is the model database. The model database essentially consists of different models, and each model is made up of different modules, such as the parts, materials, sections, and so on. So when you create a simulation, you put it inside of a model. And this model contains all of the information Abaqus needs to run the simulation. Information which you, of course, provide to Abaqus. It's possible to create multiple models within one model database. This could come in handy if maybe you've gone ahead and populated this model, set up all the aspects of the simulation, and then you think to yourself, what if I want to just change one aspect of this? Well, maybe you could go right-click on the model and choose Copy Model, and if you did that, you would find another model appearing here in this tree. If I minimize that, you'd see Model 1 and then Model 2 after that. And then you can make a small change to that model and run that simulation. Abaqus, by default, names the model Model 1. We can go ahead and give it a more descriptive name. Not so much because we need one over here, but because I want you to see how you can rename a model. So you move your mouse over Model 1 and right-click on it, and you can choose Rename. And so we're going to give it a slightly more descriptive name. I'm going to call it the Barbell Stand Model. And I will click on OK. And there you see the model's been renamed to Barbell Stand Model. The first module we're going to take a look at is the Parts module. This is where you create the 3D geometry of the part. Now, if you've worked with CAD softwares in the past, such as CATIA or SolidWorks, you have a general idea of how you create a part in CAD. In some ways, Abaqus is similar to other softwares, but it also has other differences. Because when you're creating a part here, you also have to specify what kind of analysis you're really going to be doing on it. So we'll go ahead and double click on Parts, and there you see the Create Part window. We're going to name our part Barbell Stand. In the modeling space, we're going to choose 3D because this is a three-dimensional object that we're modeling. If you were maybe doing a two-dimensional analysis where you've only got an X and Y axes, you don't have depth, this could be with maybe a sort of planar shell analysis, or maybe you're just modeling a 2D truss, or you could in fact be modeling our barbell stand but only from a 2D perspective. In that case, you'd go with 2D planar, but we're going to go with 3D. In the type, we're going to choose deformable because our barbell is essentially a deformable body. Now, it's going to be a very strong body because it's made of steel, but even steel is deformable. So we want to specify that in the type. The third category here is the base feature. You've got solids, shells, wires, and points, and we're going to go with solid. You might go with shell if maybe you're modeling the exterior fuselage of an airplane, which is basically the tube in which people sit in an airplane. And you might go with wire if you're doing a truss analysis and you're modeling each of the elements of the truss as wires and using truss elements along them. But we'll get into that stuff later. For this simulation, or this tutorial, let's go with solid. And the type we're going to choose is extrusion. You've probably heard that word before if you've dealt with any CAD softwares. An extrusion is where you create a sort of sketch and then add depth to it to create a three-dimensional object. You could have gone with revolution or sweep. A revolution would be useful if maybe you were creating a body like a disc. But in our case, we're going to go with extrusion, and you'll see how it's done in the next step. The approximate size essentially tells Abaqus, or rather gives it a general idea of how big your object's going to be, how big your part is going to be. So it initially sets you up on a graph paper that's about the right size so that you don't have to zoom in or zoom out too far. So this is not too important, it's more of a user convenience feature. So I'm going to say 5, because our barbell is about 1.5 meters high. So I want to be in that same order of magnitude. And I'm going to click Continue. What you see now is the Sketcher window. This is a 2D Sketcher interface, and I can use the scroll wheel on my mouse to zoom in and out. So I'm zooming out right now, and you see it's given me a 5x5 graph paper just because I set 5 as my approximate size in the Create Part window just a moment ago. I'm going to zoom back in on this, and we're going to start modeling our barbell. Now, one thing I should point out, when we double-clicked on parts, got the Create Part window, and then hit Continue, and it brought us into this interface, it also changed this toolbar you see on the left over here. You see, depending on which module you are, this toolbar changes accordingly, giving you the tools you need in that module. And also up here, Abaqus tells you what module you're in. Although you could just look at your tree over here and it basically reflects the same information. We're not going to look at each and every one of these tools in this video. In fact, we may not look at all of them in the entire set of tutorials. Some of them you can probably figure out just by clicking on them, playing around with them, and if you have experience with CAD, you'll pick this up pretty quickly. So we're only going to use the ones we need for the simulation, and hopefully that'll get you started. So the first one I'm going to click is the Create Lines Connected tool. I click on that, and I'm going to start out at the origin, and I'm going to draw up a basic sketch, kind of rough without dimensioning at first, outline of my barbell stand. You see, I just keep clicking and moving around. Like that. And when I do the last click, Abaqus sort of detects that I'm closing in on myself, and it helps me complete the loop to create a closed sketch. Because remember, you always need a closed sketch in order to do an extrusion. Next, we're going to apply some constraints to this. Well, you'll notice Abaqus has already gone ahead and put in some constraints. See, H stands for horizontal and V for vertical. And Abaqus sort of detected that when we were drawing, that, hey, you're trying to create a vertical line, so I'm just going to go ahead and put a V next to it and apply that constraint for you. But there's others that Abaqus doesn't pick up on its own. For example, we want this vertical segment to be the same length as this one. So what I'm going to do is go to the Constraints tool, and I'm going to click on Add Constraint. Now, constraint we want is the equal length constraint, so I click on that. And Abaqus tells me down here, select the lines for the equal length constraint. So I come over and I click on the first segment, then I hold down the Shift key on my keyboard, and I click on the second segment. And you see both of them have been lighted up in red as I did that. You gotta hold down the Shift key when you're selecting more than one segment. And then I come over here and click Done. And now you see Abaqus has added that tiny little line there that sort of tells me these are equal length. So I don't want to add any more constraints right now. I'm just going to go ahead and close this Add Constraints window. And the next tool we're going to use is the Add Dimension tool, which is over here.